mis amigos del Colegio y Puerto Rico. I am Professor Tarambetti. This month we celebrate Nuclear Science Week. We are going to learn about the importance of nuclear technology from the perspective of space. Nuclear technology is a vast domain which plays a vital role in space exploration. Exploring space simply would not be possible without nuclear technology. Inventions such as the International Space Station, the ISS for short, together with the European Space Agency satellite, provide us vital information about the Earth's wonders. Even the Mars rover Curiosity was powered with nuclear energy. They even use nuclear to research and identify the effects of cosmic radiation on astronauts and valuable equipment during a flight. These are just a few of the utilities of nuclear technology on space exploration. There are many more yet to be developed. Now I leave you with the other professor who's going to interview our special guest.
Hello, my friends. I'm Professor Hans von Puppet. This month we celebrate nuclear sciences. And what better way of learning on this special event than talking to other professionals? In fact, I got a special guest right here who's an expert in this field. Hello, why don't we start by you introducing yourself?
Hola, and thank you, Professor von Puppet. My name is Richard Wood. I'm a professor of nuclear engineering at the University of Tennessee. I teach college students about the operation, control, and safety of nuclear power plants. I also perform technical research, some of which involves the application of nuclear energy to support space exploration. Space nuclear applications generally involve power and propulsion. For example, a nuclear reactor located on the planetary surface can provide power to support habitation. Similarly, a nuclear reactor implemented on a spacecraft can provide electricity for a satellite so it can perform its function, or can supply power to enable nuclear electric propulsion to support deep space missions. Another way nuclear energy can be used to support space exploration is nuclear thermal propulsion. In that case, you have propellant flowing through the reactor core, where the core provides thermal energy, which in turn heats the propellant and accelerates it as it passes through the nozzle. In doing so, it provides the thrust necessary to propel the rocket between Earth and its destination. For example, Mars. A nuclear thermal rocket can cut the transit time between Earth and Mars by over half. Also, nuclear power can provide a lot of electricity without requiring a lot of fuel being provided on a continuous basis. So as you can see, nuclear energy and its use in space can be very vital to allowing us to maintain a continued presence in space, to support the possibility of habitation off-world, and also to enable us to travel among our solar system visiting our neighbors.
Now, what inspired you to get involved in this field?
I became an engineer because I've always been fascinated with technology. I became a nuclear engineer because I found aesthetic beauty in the nuclear interactions that occur at the subatomic level. Also, I think nuclear power is essential for meeting our energy needs. It can provide an abundance of electricity for a small amount of fuel, and it doesn't emit any greenhouse gases. I think that nuclear power is essential for sustaining our high standard of living, while at the same time protecting the planet. Now, there's another reason why I became a nuclear engineer. It seems that I share a birthday with nuclear power. On December 2nd, 1942, the Chicago pile reached criticality and had a sustained chain reaction. That was the birth of nuclear power. Now, I was also born on December 2nd, but not in 1942. Nevertheless, I share that birthday with nuclear power. So I guess you could say that our fates were intertwined. So I became a nuclear engineer, and I focused on nuclear safety and nuclear operation to enable nuclear power to provide the clean energy that it can. But I am also a space nuclear engineer, And so I would like to explain to you why I made that decision. It's mostly related to my heritage. You see, my father was an employee of the George C. Marshall Space Flight Center in Huntsville, Alabama. And through his work there, he met Dr. Wernher von Braun, who was a famous rocket scientist, was instrumental in the success of the Mercury, Gemini, and Apollo program and the landing of a man on the moon. And he later became NASA director before he retired. Through my dad's work, he also got to meet several of the astronauts. For example, Scott Carpenter, who was one of the original Mercury 7 astronauts. But mostly through my dad's work, I learned that Dr. von Braun felt that nuclear power was an essential element to space exploration. And I decided that I wanted to help realize that promise, and so I became a nuclear engineer.
Wow, that's fascinating what nuclear can achieve. Truly amazing. Now, what can you tell the young folks interested in nuclear technology?
Well, we live on a precious globe in the vastness of space. But it's always been our nature as humans to boldly go, to reach out to new places and explore, to head toward the stars. And I just wanted all of you to know that nuclear can help us do that. So I'd encourage each and every one of you to study math, study the sciences, and consider a career in engineering, and specifically nuclear engineering. Keep in mind, it's not rocket science, it's nuclear engineering, and it can help us get to space.
Well, there you have it. I hope you learned something about space exploration and nuclear sciences just like I did. It's always a pleasure to have you, sir.
You are most welcome. It was my pleasure as well. I hope that our discussion has inspired some of you to pursue engineering, and I look forward to the day that you can join me as we look to the stars. Thank you.
Oh, don't forget about me. I have another friend who would like to talk about nuclear. Hi, it's me, Phoenix.
Hi, I'm TJ Harrison. I'm the group leader for the Advanced Nuclear Systems Safety and Licensing Group at Oak Ridge National Laboratory. Part of the work that we do there is working on advanced reactor design, advanced reactor analysis, and advanced reactor systems, and part of that includes space reactor systems.
Can you tell us how does nuclear work in space?
Sure. So nuclear works in space about the same way it works on the Earth. You just use it for different purposes. So for example, on the Earth, we use nuclear power reactors to provide electricity to keep the lights on and the air conditioner on in your house. In space, we would use it for different purposes. We could still use it for electricity. We could still use it to power the spaceship. But we could also use it for propulsion. So in that case, what we would do is use the reactor as a heat source instead of an electricity source. And we would just fire, or we would pass the propellant over that heat source to heat it up and fire out the back for propulsion.
Oh, is it like if I had an endless supply of cookies in my jar?
Well, it's not an endless supply of cookies in your jar, but it's an awful lot of cookies. It's like having the same size jar, but you just keep shoving cookies down in there, and you have so many cookies in there that it'll take a very long time to run out. So that's one of the reasons that we want to use nuclear power for a lot of things. So for power production on land, for power production on ships, for power production in space. We can get energy out of nuclear material, out of a nuclear reactor for a lot longer than if it was just a tank of chemical or a tank of gasoline or oil that we burn. So it will eventually run out, but not for a very, very long time.
Is nuclear useful on Earth too?
The nuclear technology that we use on Earth has a lot of translation over into space applications. So when you're in space, there's a lot of space radiation that's just kind of hanging out. We're protected from that radiation on the surface of the Earth because we have an atmosphere and we have a magnetic field around the Earth. In space, you don't have an atmosphere or the magnetic field. So a lot of the stuff that we've learned about radiation fields and radiation safety, we've obviously learned on the Earth, and that is used for astronauts to protect them while they're in orbit on the space station to keep them safe from cosmic rays and other space radiation. Also, the development of materials. There's been a lot of material development based on the needs for nuclear grade materials at temperatures and radiation fields and stuff like that. And so working to develop those materials for nuclear applications has helped the space applications as well.
Thank you, Mr. Professional, for teaching us about nuclear.
Well, goodbye, everyone, and thank you for having me today. Take care.
I hope you learned about nuclear as much as I did. See you next time. Bye-bye.